Welcome in a new episode of Physics for Class 9, the chapter in Force and Law of Motion. Here in this episode, that is my episode 75, this episode 76, the 76th episode for the 9th class, in which I am going to solve some numerical problem which are very necessary for you for examination point of view. Here the first question, it is easy, but to start, which would require a greater force accelerating a 2 kg mass at 5 meters per second square and accelerating a 4 kg mass at 2 meters per second square. The question is, which would require a greater force? 2 kg mass or 4 kg mass to achieving the acceleration 5 meters per second hour or 2 meters per second square. To solve the problem, I have again and again I repeat that please write what is given. At first you have to write what is given. What things are, which physical quantities are given. Here, acceleration A1 is 5 meters per second square is given, and for each mass M1 is equal to 2 kg is given. And another thing is acceleration 2 for another object, that is 2 meters per second square, and the mass M2 is 4 kg. This is given to you that mass M1 is accelerated by the applied force up to 5 meters per second square, and a mass M2 having 4 kg mass is accelerated by 2 meters per second square by same force. Then what is the magnitude of the force? To find, you have to find F is what? If you write like this, then your brain extracts that which formula is needed to solve this numerical problem. It indicates that you know the value of mass and acceleration, or according to Newton's second law of motion, you know that F is equal to m into A. And now it is very easy to solve this numerical. And it is done due to the writing what are given and what you have to find. Here you have to find A, and you have a formula F is equal to m into A. Another formula is also available in this chapter, that F is equal to a rate of change of momentum in respect of time. That formula does not be applied here, because in that we need momentum. But to get the momentum, you will need the velocity of the particle and mass. Mass is given, but the velocity is not given. So that formula is not applied here. The second law, F is equal to m into A, is applied, and thereafter the force F for first object, that is mass is equal to 2 kg, and acceleration is 5 meters per second square, that is 10 kg meter per second square, and this quantity is called Newton, 10 Newton. The force is 10 Newton. You are getting here? Which would require a greater force? A force for second object, if it is F1, then F2 is what? F2 for second mass, then m into a mass of the object is 4 kg and acceleration is 2 meter per second square. Now, students, after multiplying, it is 4 kg meter per second square. 8 kg, excuse, 8, product 8. And thereafter 8 Newton. Which is greater? 10 Newton is greater than 8 Newton. And so the force required for the first object is greater than the force required for the second object that have mass 4 kg. I think that it is so easy. Now, second question I am going to describe you. I will explain you the questions very well. With the help of this, you are able to solve so many numerical problems of any book. I am going to write a second question related to this chapter. The part of this chapter, not full chapter, but part of this chapter. And the second is a motor car is moving with a velocity of 108 kilometers per hour. Question: a motor car is moving with a velocity 108 kilometers per hour. Yes, 108 kilometers per hour, and it takes 4 seconds, and it takes 2 seconds to stop after the brake. After the brakes are used, are applied. Calculate the force exerted by the brake of the one. The force exerted by the brake on the motor car, on the motor car. in mass along with this passengers take 1000 kgs. Yes, my students, the second question is lengthy. The question is, a motor car is moving with velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with passenger is 1000 kg. Now again, we will write what is given. At first, you will write the given. Yes, I am erasing this because to solve the question, I need a space. So I am erasing and then what is given, it is in front of you on your notebook. So we will write that. Or I am trying to write here the given, what are given, what things are given. At first, a speed u is equal to 108 kilometer per hour. This is the speed initial and v is 0 kilometer per hour. After applying the brake and the time is 4 seconds. Time is 4 seconds. Mass of the vehicle with passengers is 1000 kg. These three things are given in the question. First, the speed of the car, initial speed. It is moving with 108 kilometers per hour and brake is applied, then its velocity reaches to 0 in time 4 seconds and the mass of the car is 1000 kg. Then what you have to find? Force F. To find F is equal to what? Okay. Now erasing the upper part to solve the numerical. Yes. The time is in second. So, and the speed is an hour. So you have to make it similar. Yes, because which formula is applied at first you think. Here, the initial velocity is given, the final velocity is given, mass is given, and time 4 seconds is given. It means we know that the rate of change of momentum is equal to the applied force, you know very well. This is also second law in terms of momentum. So you are able to calculate the initial momentum u into a final momentum. This, then you are able to by time t you are getting 4 seconds, then the force will be calculated easily. So for that, at first you have to change the kilometer per hour in meter per second. Because the time is given in 4 seconds, so we will convert it into meter per second. So U is equal to 108 kilometer per hour into what? To change the kilometer, you will multiply 1000, and to change hour in second, you have to multiply this. 2 0, this is 5 and this is 80. This is also a formula to convert the kilometer per hour into meter per second. If you multiply the kilometer per hour by 5 by 18, you will get the velocity in meter per second. To describe this, I have written like this. Otherwise, I will write 108 km per hour multiplied by 5 by 18. Okay, my children? And now, it 108 into 5 by 18. If you solve it, then the answer is this meter per second. I have already calculated in my answer set. So I am writing this. You have to calculate that 30 meter per second. You know very well. And now, there are two processes, and you know very well V is equal to 0. Therefore, rate of change of momentum, F is equal to rate of change of momentum, final momentum minus initial momentum by time. The final momentum is 0. Initial momentum is equal to m. Mass is how much? 1000 kg. And velocity, initial velocity is t meter per second. And time is 4 seconds. To solve it, you will get 4 2 8, 4 5 100. This. And this is equal to now 0, 0, and 1, 7. This is 7500 Newton is the answer. First way to solve this, and second way. It is also easy to solve by second way, that is F is equal to M into A. And thereafter, this is M is equal to V minus U by T. And all values are given. The same equation you are going to solve. M into V, final momentum, M into U, initial momentum by time. Then again this number comes and you have to solve. It means the formula is F equal to Pf minus Pi by time is similar to the F is equal to M into A. Okay, my students, by these two ways, you are able to solve this numerical. But it is easy because you have written what is given. If you write before solving the question, then the numerical seems to be very easy. Otherwise, not. It seems difficult. Now, a third numerical problem for you. The question is very, but I want to solve it because it is a very important question, hot question, maybe for you. So I am writing here and then I will erase it. The question is, a constant force act on an object of mass 5 kg. A constant force, question number 3, a constant force act on an object constant force act on an object of mass 5 kg 5 kg for 2 seconds. Okay? It increases the object's velocity. It increases the object velocity from 3 meters per second to 7 meters per second. Okay, my students, find the magnitude of applied force. Find the magnitude of applied force. Applied force. Now, if the force were applied, now the force were applied for a duration of 5 seconds. 5 seconds. 5 seconds. What would be the final velocity of objects? What would be the final velocity of object? No, right, give it. Give it. What are you giving? An object of mass. The mass is given 5 kg for 2 second time T1 2 seconds. It increases the object's velocity and initial velocity. Initial velocity 3 meters per second. Final velocity is equal to 7 meters per second. Find the magnitude of applied force. Yani, to find it is what? Now the force were applied for a duration of 5 seconds. Again a time, next time it is T2 H 5 seconds. Then final velocity. Here initial and final U1 and D1, then V2 is what? Okay, my children? See, mass is given, time is given, initial velocity is given, final velocity is given, and then the question asks, the force say, it is very simple that the rate of change of momentum is equal to applied force. You go on, yes, A is equal to P2 minus P1 by T. Final momentum, what? Mass is 5 kg and velocity final is 7. You have written into 7 meters per second minus P1. Mass is 5 kg and velocity is 3 meters per second. And the time 2 seconds. It is 35 kg meter per second, which is the unity of the momentum, and 15 kg meter per second by 2, and 35 minus 15 is equal to 20 kg meter per second by 2 seconds. Second cancel means no, cancel it. It is multiplied to no, it does not cancel, but they multiply with each other. Second, therefore 2 is 10 kg meter per kg meter second. Kg meter is equal to here. Yes, is cancel. Okay. 10 kg meter is equal to Newton. It means the force is 10 Newton. The force acting on the object is 10 Newton. And the second part asks that if it is applied 5 seconds on the object, then what is the final velocity? Isn't the question? A duration of 5 seconds, what would be the final velocity of kya hona chahiye final velocity of the object? Here I am erasing this part. You know, F is equal to M into A, and M into A is equal to V minus U by T. Yes? You know the value of A, 10 Newton. You know the value of mass, that is 5 kg. You know, you do not know the final velocity, but you know the initial velocity. What? Find the magnitude of the applied force. Now the force we are applied for a duration of 5 seconds. Which velocity taken an initial velocity, can you imagine? Can you imagine that which velocity is taken as initial? I am giving a moment for you to think about this. And the answer is 108 kilometers. No. What is the velocity? A constant will act on an object of mass 5 kg for 2 seconds increases the object velocity from 3 meter second to 7 meter per second. Yes, the final velocity is finding the magnitude of the vector. Now the force were applied for a duration of 5 seconds. The initial velocity is 3 you will take per second, and time is for how much? 5 seconds. Yes, 5 cancel. Yes, therefore 10 v minus 3 meter per second. Therefore, final velocity is equal to 10 plus 3 is equal to 13 meter per second. Just here I have solved this problem already. Yes, my students. In this way, I have solved the 3 questions. Now, a fourth question I am going to solve, which is very interesting to you. See, a force of 5 Newton, question number 4. A force of 5 Newton gives an acceleration acceleration 10 meter per second square in a mass M1. And a mass M2 is accelerated by the same force by 10 meters per second. 20 meters accelerated by 20 meters per second square. If both are dead, both objects are tagged or tied together, then find the acceleration. Find the acceleration. A 5-meter force accelerate a object having mass m1 by 10 meters per second square, and another object having mass m2 is accelerated by 20 meters per second square. Then if both m1 and m2 are tied together, then what is the acceleration produced in that object? The m1 and m2 force is known. F is given. Force is known 5 Newton. Acceleration A1 is known 10 meters per second square. And for this m1, mass is equal to m1. And again, force is same 5 meters. The acceleration produced A2 is equal to 20 meters per second square, and for mass m2. Then first you have to find m1 plus m2 for this acceleration. Is what? Calculate. At first we have to calculate the mass, because the mass is unknown. And this is found from the formula A is equal to m into A. Therefore, m is equal to F by A. The force is how much? I spent 5 Newton, and the acceleration produced is 10 meters per second square, 5 to the 10, and therefore the answer is half kg. And for second object is m1, and m2 is what? m2 is force by acceleration A2, this is A1, and force is same 5 Newton, and the acceleration produced is 20 meters per second square. It cancels it. 4 acceleration 25 Newton. Yes, 1 by 4 kg. Yes, you have find the mass. Now, when you join together it, that the m1 plus m2 is what? m1 plus m2 is equal to 1 by 2 plus 1 by 4. LCM 4. This is 2 plus 1, 3 by 4 kg. Therefore, question is, what is the acceleration? In it, what is the acceleration is produced by the same force by Newton, formula A is equal to m into A, therefore A is equal to F by m. The Newton force is 5 Newton and mass is 3 by 4 kg. It means you have to write it 5 by 1 into 4 by 3, that is 20 by 3 meter per second square. This is the solution of this question. I think that it is also clear. And now the last question I am going to solve, which is related to the graph. And it may be possible for the examination point of view. It may comes in your examination. Your teacher will ask this question. Maybe this type of question is asked by the teacher. A graph is given. Question number 5. This is the graph is given to you for a ball moving on a long table. Okay? The velocity time graph, the graph between, this is velocity, which is given in centimeter per second, and the time is given in second. Between these two physical quantities, this graph is drawn. The velocity time graph of a ball of mass 20 grams. Mass is given 20 mass 20 gram. Next. Only this is given. A 20-gram ball is moving on a straight on a long table. How much force does table exert on the bar to bring it to rest? How you will find it? Mass is only known. You know two formula for force. Force is equal to m into a in this chapter, and force is equal to P2 minus P1 by T. Only here mass is known. Acceleration is unknown. But a graph is helping you, which gives information about the acceleration. You know the velocity time graph slope gives the magnitude of acceleration. So accelerate slope of graph. Slope of graph is equal to 20 centimeter per second by time 10 seconds. It means 2 centimeter per second square. So, अरे कुछ नहीं कर सकता हूँ मैडम ने जिस सारा काम करता हूँ थी मैंने जिस सैलरी में दिया है पढ़ने के अलावा फंसा हुआ हूँ और कुछ शुरू हुआ है मैं कर दिया आता हूँ तो आपके लिए क्लास जो शुरू है सबसे बात है अभी स्थिति में ये 3 महीने से न सैलरी दिया इंस्टीट्यूशन में कुछ तो भी घर आके घर में डाल दिया मैं यहाँ अरेंज करता हूँ तो आपके इंस्टॉलमेंट को डाल जी मेरी फैमिली पढ़ता ही रहती है मेरा पोता वही पढ़ता है मेरी वाइफ मेरी बहू वही रहती है बेटा वही रहता है इसलिए सोचा ठीक ओके जैसा हो मैं सितंबर तक तुम लोन मांगिए नहीं सकते फोन क्या करते यस excuse me students the call has come so I have disturbed. The slope of the graph is this, and this gives the magnitude of the acceleration 2 centimeter per second square. Then you are able to calculate the force. F is equal to m into a m. Mass is how much? 20 gram. Force is calculated in kg, not in gram. So you have to convert the mass into kg. It means 20 by 1000 and to acceleration centimeter is converted into also converted into meter, but if you have to convert this 2 centimeter per second square in meter per second. I am here converting to 20 centimeter by 10 centimeter. 10 is equal to millimeter. Now 100, that is 100 centimeter is equal to 1 meter. You have divided and it is second. So you have to divide the second in meter. The Newton is kg meter per second, or time is not changed. So the centimeter is equal to into 10, 10, 20, 50, and 1 by 50 meter per second square. 1 by 50 meter per second square, you have to take the acceleration and acceleration. 1 by 50 meter per second square. And it is de-acceleration, so the magnitude is minus a. Because it is de-accelerating, the final velocity is 20, initial velocity is 20, and the final is 0. It means 0 minus 20 is equal to minus. You have to write it minus. 2 centimeter, the acceleration is 1 by 50 meter per second. Therefore, it is 1 by 50 meter per second, 0, 0 cancel. 5, 0, 0. This is 1 by 2, 5, 3, 0. And if you calculate it, then the result will come minus 4 into 10 to the power minus 4 into 10 to the power minus 4 Newton. But 25 minutes, we 10,000 भाग देंगे 1 lakh में तो 4 ही आएगा in case, and the 0 is 4. So this is the answer of this graphical question. And in this way, my students, I request you that please do practice for your numerical problems, because in the board examination, about 13 marks numerical question comes in the examination. So please be alert for this. Start your practice from this class, and if you are getting any trouble, then you will ask on WhatsApp group, not extra, but only related to this chapter. You will ask, I will help you, I will support you, I will solve you. Okay? Make a nice day. God bless you. Thank you. कितना हुआ?